All right, guys. So we're jumping into systems of linear inequalities. Okay. What is the equation that we graphed? What is the algebra 1 equation? Y equals mx plus b, right? That has not changed, okay? So here's what's going to change in today's graph. We're going to talk about, okay, if we do y equals mx plus b, which we know that, right? This is still the same. What is m? That's your slope. What is b? That's your y-intercept, okay? So if I graph this, so like let's say I have an equation that says y equals 2x minus 1, yes? So I graph this. What's my y-intercept? -1. So I go -1. I put a dot because -1 right there. Why did I put it at -2? That's not right. Okay. -1. Yes? What's my slope? 2. 2 over 1. So I'm going to go up 2. So 1, 2, and then over 1. Is everybody with me? So that would be my line. Do you guys remember that? You guys remember y equals mx plus b? Now, what's going to change now is instead of saying y equals mx plus b, now you're going to have an inequality. Who knows what an inequality is? Yes? What are you doing? I see hands doing this. What is that? Less than or equal to, greater than or equal to, okay? So here's what we're going to have. Instead of saying y equals mx plus b, I'm going to change this to like y is greater than 2x minus 1. Okay, so the graph doesn't change. The slope, everything stays the exact same. Everybody stick with me on this. This doesn't change. So if I graph this, it doesn't change my line. But what happens is on this line right here, there's two things that happen. Number one, if I have just an arrow, it becomes a dashed line. Okay, now it's a dashed line. Kind of like, remember when we did open circle, closed circle earlier in the semester? Like, give me numbers that are greater than 5. 6, 8, 6, 7, something like that, well, whatever. Okay, so we have all these numbers that are greater than 5. Give me a number that's greater than or equal to 5. Everybody does that. They always say that number, 5. Yep, that's when it would be a solid line. So here's what I want you to write down somewhere on your notes. Okay, so please write this. If you have a less than or greater than, it's going to be a dashed line. Okay, everybody with me? And actually, I'm going to do it like this. I'm going to put dashed line over here on this side. Okay? If it's less than or equal to, or greater than or equal to, it's going to be a solid line. Okay? Is everybody good somewhere? Oh, everybody good? Now, do this. Now, if you notice, less than, right? I'm going to shade below. And I'll explain what that means in just a minute. Okay, shade below. If it's greater than, I'm going to shade above. That's exactly right. And I'll tell you what that means here in just a second, okay? Shade above. Okay, is everybody okay so far? Yes? Now, obviously, you're like, I don't really know what the heck you mean by that. How many of you are just a little bit like, what? Okay, couple of hands kind of sliding up. It's going to make sense here in just a second, okay? Just kind of like I just said, what numbers are greater than 5? You said 8, 9, 6, 7. Okay, you said all these different numbers. I see the hands going. We were at a basketball tournament this weekend. We were watching Argyle play. I know I really don't care. We were watching Argyle play. Argyle had 65 points. And our girls are getting excited. They're like, yeah, the freshman girls, they're all pumped up. They're getting ready to, because if they get another basket, they're probably going to have what? 67 points, right? They get a fast break. Our girls are starting to celebrate. Coach calls timeout. He tells the girls, do not score. Do not score. So the girls like literally came out and they just passed the ball around for a minute. One girl had the ball underneath the basket with nobody standing around. She would not shoot the ball. And our girls were like, no! Like they wanted to do it so bad. And the coach, I was talking to him after the game, he said that he did it just to mess with people. So, but they won like 25. He just didn't want to get to 67 points because of that very reason. So it was actually really funny. All right. We good? Shade above, shade below, whatever. 6, 7. Yeah. All right, here we go. Y is less than or equal to -x plus 1. Here we go. Now, what's my y-intercept, guys? Oh, you don't have this on your notes, so let's just talk. You do not have this one on your notes, so let's just talk through it. The ones that you have on your notes are compound. You're going to have the systems of equation, which is more than one equation. We'll talk about that in a minute, but I'm just kind of showing you how this works, okay? How do I graph this? What's my y-intercept, guys? Positive 1. Okay, so positive 1. Yes? Now, that takes care of the 1. Now, what's my slope? Negative 1. So I'm going to go negative 1. I'm going to go down 1 over 1. So down 1 over 1. So there it is. Now, I'm basically working backwards, okay? Positive 1, I did my slope. Now my arrow. Is it a solid line or is it a dashed line? Nope. Does it have a line underneath it? No, so it's going to be dashed. So I'm going to draw, now I'm going to kind of do this just so I have it. It's going to be a dashed line all the way down and all the way up, yes? Okay, is everybody with me so far? Now, I'm going to show you what this means here in just a second. So I want you to fully understand what we're doing, okay? Now, it's less than. So do I shade above or shade below? Just kind of what does it sound like? Less than is going to shade down or up? Less than. Down, okay? So here's how you do this. Everybody look, because I don't want to explain this a whole lot. Go to the y-intercept, and I'm going to shade everything down from the y-intercept. So everything on that side of the line is shaded. In other words, what this means is that everything in the shaded area should be true. Everything in the shaded area should work in that equation. Think about it like this. You guys remember doing these? Open circle, closed circle, like positive 5, open circle to the left. You guys remember doing those? And I told you everything that was on the left-hand side was true in the equation. Do you guys remember that? Same thing on this, but now you have two different equations. So now let me show you this. Let me show you one point just to prove this to you. One point that is very, very obvious that is in this is, would you say 0, 0 is in the shaded area? 0, 0 is, yes? So what I'm going to do is I'm going to plug in 0, 0 just to show you that it does work. Anything in this area should work. 0 is greater than negative 0 plus 1, right? Now, nothing to change there. What's 0 plus 1? Is 0 less than 1? True. It's in the shaded area. It works. So we're looking, that's what the shaded area does. Y equals mx plus b means everything on the line is equal to it. When you're talking about shading, you can have all these infinite numbers in here that will work. Okay, if this graph was bigger, it would extend all the way down. That's what it means. Does everybody understand? Everybody cool with that? All right. Yes? It is pretty easy. Once you understand graphing, the only thing that really changed is which way is the shading and are you using a solid line or dashed line. Really, nothing else has really changed. Everything else stays pretty much the same, okay? So there's not a whole lot of new stuff that goes with this, okay? Like I said, the very beginning of the notes usually take the longest. I'm not going to go through all the ones. I think number 2, okay? What's wrong with this one? What's wrong with it, guys? So how do I get it in y equals? Move the x divided by y. So here we go. We did this, didn't we? We've done a ton of these. So move the x. Positive 2x becomes a what? Negative. So I'm going to put negative 2x over here. So I've got negative y is greater than or equal to negative 2x minus 4, yes? Now what? Can I have a negative y? So what do I divide by? Negative 1. Negative 1. Negative 1. Y is, hold on. When you multiply or divide by a negative, let's see who remembers. What do you have to do? What? You've got to flip the arrow. Remember that from earlier in the year? When you multiply or divide by negative. We had this. You had like negative 2x is greater than 4. And I told you divide by negative 2, divide by negative 2. X is less than negative 2. You had to flip the arrow. When you multiply or divide by negative, it doesn't matter. If you have an inequality, when you multiply or divide by negative, you have to flip the arrow one way or the other. It is a 100% rule. So this is now less than or equal to 2x minus 4. There's my equation, and I can graph it. This one would be negative 4. I'm going to do it very, very quick. That takes care of that. Up 2 over 1 takes care of that. This one, is this one solid or is it dashed? It has a line. Listen, here's the rule I always learned. If it has a line, it is a line. If it has a line, what is it? It is a line. Okay, a solid line. And I'm going to just draw my solid line. And it's less than, so do I shade above or below? Below, so I'm going to go here, below the y-intercept. So everything on this side is true. Is 0, 0 shaded? No. So if I put it in there, should it be true or false? Should be false. Let's check it. What's 2 times 0? 0. What's 0 minus 4? Is 0 less than negative 4? No, it is not. 0 is actually greater than negative 4, so that's false, which is why it's not shaded. Okay? Just kind of proves it to you. Everybody good? All right, let's talk about systems. Now, when we're talking about systems, we're going to our main notes that we had before, okay? We're still talking about the same thing that we just did. Now, stick with me on this. Don't yawn. I'm not that boring, am I? No, not at all, Coach Boy. Okay. Now, systems of inequalities. We're going to rearrange by putting, no title. So y is by itself. I don't know why it's on there. Graph the inequality. Now, we're going to have two different shadings. What were we looking for when we were talking about a system of equation? The test that you just took last week. You were looking for the what? The coordinate where they what? Where they intersect. When they intersect. You're looking for just the x and the y, right? That's not what you're looking for now. Now you're going to have a shading here and a shading there, and you're looking for the what that overlaps? What do you think? If you have two different shading areas, what do you think you're looking for? The shading that overlaps. That's what you're looking for, okay? Everybody with me on this? Your calculator will do this, but Desmos will also. Now, Desmos testing calculator will not shade for you. The regular Desmos will, but you're not allowed to use that on the STAR test, so I need to show you how to do this, okay? It will graph like y equals 2x minus 1, but it won't do the shading and all that stuff. It won't do it, okay? So you can at least check the y equals to see if the graph looks right, okay? Everybody good? All right, let's try this. You guys have your notes, right? First one, is it in y equals? Yes or no? Look at it. Is it in y equals? No. So what do I need to do? Move the x. So I'm going to move. What kind of x is it right now? Negative what? Negative 3. What's it become, guys? Positive 3. So I'm going to put plus 3x. I'm going to put plus 3x over here. I'm trying to find a marker I like. Y. Oh, there it is. Did I divide by negative? Do I need to flip the arrow? No. So don't flip the arrow. 3x plus 2. Correct? Everybody good? Write this down. These are on your notes. Guys, this is on the back page. Oh, it's on the front page, actually. So 3x plus 2. What's my y-intercept? Positive 2. And my slope is 3, right? So I'm going to go up 3. 1, 2, 3, and over what? 1. Up 3. 1, 2, 3, over 1. 1, 2, 3, over. I just keep doing it just because I want to have a semi-straight line. You don't have to do it this many times. Down 3. 1, 2, 3, over 1. 1, 2, 3. Is it going to be solid or dashed? Look at the arrow. This one is dashed, so it looks like this. Yes? Now, hope. It's greater than. Do I shade above or below? How do I do it? I go to the y-intercept, and above goes which way, up or down? Up. So everything on this side is shaded. I know that's weird. It looks like left, doesn't it? But it's above the y-intercept. You guys with me on this? Is everybody okay? Everything on this side is shaded. Now, I need to change colors because I'm going to do a different equation. I'm going to pause it really quick. Everybody divide by 3 and go ahead and change it. Now, if I'm dividing, actually I'm not going to pause, but I'm going to let you work on it. If I divide by 3, do I flip the arrow? Hold on, did I divide by negative? Then don't flip the arrow. Only when you multiply or divide by negative. Yes, ma'am. You have a question? Now I'm just going to work it out with you. Divide by 3. Divide by 3. Leave the fraction. The fraction is good. The fraction is your friend. Because I want slope to be a fraction. Okay? Divide by 3. Y is less than or equal to negative 2/3 x minus 2. Everybody good? There is a way to do arrows on your calculator. I'll show you that here in a minute. Okay? Everybody good on this? So let's graph this one. Negative 2. Please watch. Please, please, please watch. This is where everybody seems to be okay usually when I do the first one. Okay? When I start throwing a second line on there is when people are like, okay, you kind of lost me. So just stick around for this, okay? I'm focusing only on green. Don't worry about the black. Is there what color, guys? Green. Focus on the green. Just don't worry about the black yet. Okay? Negative 2/3. So I'm going to go down 2, right 3. 1, 2, 3. Yes? Down 2, right 3. And so I'm going to go up 2 and left 3. 1, 2. Basically, because I want to go the other way too. Everybody good? Okay, you see my dots. Solid line or dashed line? This one's going to be solid because it has a line, so it becomes a line, yes? Solid line. Now, here's where it gets tricky. It's less than. So do I shade above or shade below? Below. So I'm going to go to the y-intercept, and everything on this side is shaded, yes? All the way up and down this line. Can you guys see where the overlap is? Where's the overlap area? The bottom, would you say bottom left? So this area right here, I'm going to circle it in red. You guys with me? Would you say that entire area right there? That is the solution. We're looking for the overlap of the shaded areas. That's all you're looking for. Where does the overlap on the shading work? You guys, does that make sense? I see a lot of nodding. Does everybody understand what's going on? Yes? If you can graph one line and you can graph a second line, you should be okay. But if you don't know how to graph, then we're kind of stuck. Remember how we told you guys you need to remember y equals mx plus b and how to graph y equals mx plus b? We're still going to come back to it. I mean, we're still in y equals. Now it's just an arrow. Okay, so it's the same stuff. Cool? All right, let's see what the next one looks like. By the way, 0, 0 is not shaded. I'm not going to test it because, well, whatever. Okay, so here's the question at the bottom. Is 5, 1 a solution? Is it a solution, yes or no? So 5, 1. So I go check. 1, 2, 3, 4, 5, 1. Is that a solution? No, it is not. It is not a solution. If it was on a dashed line, it's not a solution. Everybody just hear that? If you get a solution that's on a dashed line, is that a solution? No. It's kind of like, it goes back to the question, give me numbers that are less than 5. 4. Is 5 less than 5? No. That's less than or equal to. So if it's a solid line, it can be a solution. But if it's a dashed line, it doesn't work. Okay, everybody understand that? Okay. All right, let's go to, you know what? Yeah, I'm going to pause the video and let you work on this for just a minute. Fair? All right, let's go ahead and get started. Go ahead and start on this one. Get y by itself. All right, guys, we're back with a fresh cup of coffee. All right, here we go. First one. What do I do? Move the 5. So it's going to be y is less than 1/2 x plus 5, yes? Do I have to flip the arrow on that one? I'm always going to, did I multiply or divide by negative? No, I did not, so don't flip the arrow, okay? Here we go. Positive 5. 1, 2, 3, 4. Well, 1, 2, 3, 4, 5. There it is. And my slope is 1/2. Positive or negative? Positive, so I'm going to go up 1 over 2, yes? If my slope is positive, my line should also be positive. Would you agree? Yes, make sure your answer makes sense. Okay, so this one's solid or dashed? Dashed. There we go. Now let me ask you this. Do I shade above or below? Now hold on, what's that? That's less than. So what I do? Bless. I'm going to bless this equation. Okay. Yeah, I'm shading below. Yes? Shade down. I'm going to give myself room to work. Everything below the y-intercept. Everything below the y-intercept. What's my key point? The what? The y-intercept. Okay. Now, what do I have to do on this one? Move the x and then what? Divide by y. So positive 4x becomes a what? So I got negative 4x over here plus 16, correct? I just moved the 4x to the other side is all I did. I didn't draw the arrow that time. Does everybody know what I did? I took positive 4x and made it what? Negative on that side. That's all I did. Very good. Now I divide by what? Negative 8. Divide by negative 8. Divide by negative 8, correct? So I'm going to flip the sign. I don't like, oh, I'm sorry, that's 16. Sorry. So here we go. Y is greater than, what's 4 over 8? That's half. 1/2 x. And then minus 2. 16 divided by 8 is 2. Why do we flip the arrow? I promise you it's going to be on your test. I promise you you're going to have one where you have to divide by negative. How many times have I asked you, do I flip the arrow? Every single question that I've done. I'm telling you it's going to be there. And you're going to see it on your STAR test. It's going to be there. You are going to have a question where you have to flip the arrow. I don't know what else. Like, it's going to be there. Okay. All right, here we go. 1/2 x minus 2. So here we go. Minus 2. Positive 1/2 x, correct? Now up 1 over 2. Oh, what do you notice about these? Say it. They're parallel. Does that mean that there's no solution? No, it doesn't. Not in this. When we're talking about linear systems, we're looking for the point where they cross. That's not what we're looking for. We're talking about inequalities. We're looking for the shading that overlaps, right? So there's still a chance that this could work, okay? So just because they're parallel doesn't necessarily mean no solution when you're talking about systems of linear inequalities. Does that make sense? We're looking for overlapping shading. So here we go. This one's going to be a dashed line, yes? Now, it's greater than, so which way do I shade? I'm going to go to the y-intercept and I'm going to shade up. So what area is my overlap? What's the overlap, guys? I see people pointing. Tell me. Right in the middle. So that means all of this area, all of this is the answer. You guys with me on this? This entire section right here is my answer. That means anything in either one of those points will work. Hold on. Is 0, 0 one of the points? Yeah. Yes, it is. So let me ask you this. Let's see if that works. Want to try it? Let's put it in this one. Fair? 0 less than, what's 1/2 times 0? What's 1/2 times 0? 0 plus 5. So is 0 less than 5? True. And I bet it's going to be true down here too. 0, that becomes 0. Is 0 greater than -2? True. It works. It works in both of them. The point is it works in both equations because it's an inequality. So just because they're parallel doesn't mean you're not going to have a solution. Fair? Everybody understand that? Is -2, -3 a solution? So let's go to -2, -3. -2, and then down 3. 1, 2, 3. Here's that point. Is that a solution? What is it on? Hold on. It's on a what? So is it a solution? No, it is not. If it's on a dashed line, it is not a solution. If it's on the dashed line, it is not a solution, guys. It's everything from here up, not the part of the line. Kind of like we had open circle, closed circle on the 5. You guys remember that? The 5 is open, but that doesn't make it part of the solution. That's just our starting point. Okay. I hear some O's. Make sense? If it was a solid line, would it work? Yes, it would. Yes, it would. Okay. Everybody good? All right, let's go. Let's do one more. We got time. Oh, I love these. I'm going to give you time to work with your neighbor, see if you can figure this one out. Now, if you don't remember, graph x equals and y equals and change it from there. Okay, if you guys remember that. Remember the words hoy and vux we talked about? We did it. I've done it several times with you guys. Horizontal, hoy, 0 slope, x or y equals. Horizontal, 0 is y equals. Vux, vux, vertical, undefined, x equals. You guys remember that? Y equals, x equals. I see some nodding. See if we can figure this one out. Go. Talk to your neighbor, guys. There's not a whole lot of talking. Do not be scared to be wrong. All right, here we go. Unpausing. X is less than 8. So what axis do I go to, guys? What letter does it give me? X. What number? 8. So on the x-axis, I'm going to go to 8. Now, I went to the x-axis, which means I go which way from my line? It's always opposite. So I'm going to go vertical. Now, is it going to be solid or dashed? This one's going to be dashed. Yes? You guys remember this? Every point up and down this line is 8 something. You guys remember that? Every point up and down. That's why it's vertical. Every point is 8 something because we went right 8 and up 7, 6, 6, 7. Okay. Down 3. Okay. It's all. Go ahead, Hope. Yep, she's good. Just let it out. Yeah. Now, here's the tricky part. It's less than. Now, this is the only one that's not above or below because it's a vertical line. Okay. So because it's a vertical line, if it's less than, which way do you think I shade? No, I can't. I can't go up and down. Less than. Which way would be less than on a number line? Left. Okay. This is the one that goes to the left. Everybody with me? This is the only one that doesn't go up or down. This is kind of like that open circle, closed circle thing we did before. Remember, letters left, numbers right. Yeah, I heard somebody say it. Okay. Left is less than. Okay. Left hand, less than. Left hand. Okay. All right, here we go. Let's do the other one. Now, what letter does it give me? No, that's not a letter. Y. So what letter? Y. So on the y-axis, I'm going to go to what number? -5. So -1, -2, 3, 4, 5. Yes? Now I'm paying attention to what letter now? What color? Green. Don't pay attention to the red right now. Just pay attention to the green only. Yes? Pay attention to the green. Okay, watch. So I'm on this point right here. Just kind of zone out the red. I'm right here. Y is greater than -5. So if I go to the y-axis, which way is my line? Horizontal. Remember Hoy Vux? Remember? You guys remember that? So is this one solid or dashed? Solid. So I'm going to go just solid line straight across. And this one is greater than. So do I shade above the line or shade below the line? Above the line. Oh, what do I have now, guys? Look, what can you tell me about squigglies? They're crossing. So my solution is basically from this line. Wake up. My solution is from here to this line. Basically, this whole area right here is double. Okay, so here we go. Is -5, +5 a solution? -5, +5. That's right there. Is that a solution? Yes, it is. And here's how you know. Everybody look. -5 X number. Is that less than 8? True. +5. Is +5 greater than -5? Yes, both of those numbers work. X, Y. So it works. Huh? Well, this one just because you only have one variable. This one has the X, this one has the Y. You just plug them in. Is everybody, how many of you, how do you feel on this, 1 to 5? Okay, now let me ask you this. Forget about the graphing part of it for just a minute. How do you feel 1 to 5 on the what we're looking for? How do you feel on the shading part? Like you understand what we're looking for. Okay, the numbers are higher. How do you feel on actually graphing? Go. Okay, numbers are a little bit lower. That's fine. I get that. But that's stuff that we've worked on before. So we can work on that, yes? Everybody good? We're going to work on that a little bit, okay? So remember, what we're looking for when you're talking about the linear inequalities is we're looking for the overlapping shaded area, okay? The overlapping shaded area. Let me see if I want to do one more. I don't think we need to. You guys think we're okay? Think we're fine? I think we'd be beating a dead horse right now if I just kept going. Okay, it's the same questions over and over again. All right, go ahead and take a break. And if you have any questions, just ask, okay? If you're watching this online, comment below, share. Share it with your friends. Share it to your socials.